Hi everyone, welcome back to another video at Talent 500 YouTube channel. I am Kushal Vijay and I'm a software engineer and a content creator on YouTube. In today's video, we'll be covering each and every bit of it in detail. If you have any doubts, please make sure to comment it down. This particular video is a part of our full stack development series. You can check all the other videos in this particular series which have been published previously. You will learn a lot and it will help you gain more momentum in your preparation for getting jobs at big tech companies. So without any further ado, let's get started with the video. So let's get started with our Spring Boot 101 interview series. We'll be answering advanced interview questions asked by top tech companies around this domain. So let's get started. The first question is, what is dependency injection? This particular topic is very important when it comes to the topic Spring Boot. So the process of injecting dependent bean objects into the target bean objects is called dependency injection. Now you need to have the basic understanding what is dependent bean objects and what is a target bean object. Being a senior experienced individual, you are expected to have this prerequisite, but I'll still brief it down. In brief, you can understand them as Spring objects. Now there are multiple ways with which dependency injection can be done. One is setter injection, the other is constructor injection, the third is field injection. Each of these injections have something different. If I talk about the setter injection, in this the IOC container will inject the dependent bean object into the target bean object via the setter method. Now what is IOC container, you might be wondering. We'll be discussing about it in some time in detail. Then what is a constructor injection? A constructor injection is nothing but when a IOC container will inject dependent bean object into the target bean by calling the target bean constructor. Keep this in mind, by calling the target bean in constructor. When it comes to field injection, this particular injection from the dependent bean object into the target bean object is done by a reflection API. This is the difference between the three, via the setter method by calling the target bean constructor and via the reflection API. And these are the different ways with which dependency injection is done. An IOC container is nothing but a framework to facilitate this. We'll be talking about it later. Let's move on to our next question, which is, what is the difference between Spring Data JPA and Hibernate? Hibernate is nothing but a Java persistent API implementation. Hibernate, it facilitates object relational mapping, which is ORM, allowing user to store, retrieve, map and update application data to and from the Java objects and relational databases. So basically, in order to allow the user to do the CRUD operations to and from Java objects and relational databases, Hibernate helps. So Hibernate maps the data types in Java to SQL, which is structured query language, and the classes in Java to the database tables, relieving developers from scripting data persistent SQL programs. So this is what a Hibernate work is and what it do. Whereas when it comes to Spring Data JPA, which is Spring Data subproject, on the other hand, it gives abstraction over the DAL, which is the data access layer, applying JPA, which is Java Persistence API, and object relational mapping ORM implementations such as Hibernate. So Spring Data JPA is nothing, it just gives the abstraction over data access layers, applying ORM and JPA implementation such as Hibernate. Okay, so it only gives the abstraction part to the data access layer using Hibernate. Now, Spring Data JPA facilitates smooth implementation of Java persistent repositories, and it intends to improve the overall implementation of data access layer to a great extent. So this is the crucial difference between the two, where Hibernate facilitates the CRUD operations, whereas Spring Data abstracts the data access layer using Hibernate. I hope you folks have understood the core difference between the two. Let's move on to our next question, which is, how are REST controller and controller annotations different? So the traditional Spring controller annotation, so annotation is nothing but a property kind of thing which is added over classes and functions, whereas a Spring Add controller annotation specified that a class represents a controller. So you might have heard about MVC architecture, which is followed in web application model view controller architecture. So if a annotation of controller is being added to a class, that means that class represents a controller. So it's basically a component specialization, and it is auto detective via the class path scanning. Now the controller annotation is used along with the annotated handler methodologies based on request mapping annotations. So these controller annotations are used along with the annotated handler methodologies, which are based on the request mapping annotations. Now, how it is different from a REST controller annotation? So developers use the REST controller annotation to develop RESTful web services utilizing the Spring MVC model, which is the model view controller model architecture. The Spring REST controller maps the request data to the specified request handler method. So for example, if a request is coming, based on the data in the request, it has been mapped to a particular handler method in the view, and this is what REST controller do. It maps that thing. Once the handler method generates the response body, the REST controller modifies it to XML or JSON based on the type of response need to be given. So this is the work of a REST controller, where controller only specify the class being the controller, and whereas the REST controller do the mapping as well as generates the response body. Let's move on to our next question, which is, if an interviewer asks you what is your experience implementing microservices using Spring Boot, you have to explain it in this manner. You first have to explain like implementing microservices using Spring Boot, which involves breakdown of monolith application into smaller independent services that can be developed and deployed and scaled independently. So you have to give an instance of from your experience where you have done this thing of disintegrating a monolith application into smaller and independent services which are loosely coupled with each other and independently scaled. So Spring Boot provides a number of features and tools that make it easy to build and deploy microservices. Spring Boot is very popular, and it's highly being consumed when it comes to developing microservices. So if a question is being asked to you, how do you approach service discovery and communication between microservices? Now, this is very crucial when it comes to developing microservices using Spring Boot, because if there needs to be communication between different services in order to facilitate the web application. So you need to explain it in this manner. You need to specify the best approach to service discovery and communication between microservices in a Spring Boot application is to use a service registry and a client-side load balancer. Now let us first understand what is a service registry and what is a client-side load balancer. So a service registry is nothing but a database which is used to keep track of available instances of each microservice in an application. And when it comes to a load balancer, a client-side load balancer, let me give you a brief of it also. So a client-side load balancer is similar to what a general load balancer do. It distributes load optimally across available servers. So this is what a client-side load balancer is. So there are several open source tools and frameworks available for implementing service discovery and communication in a Spring Boot application. There are some popular choices. For example, the Netflix Eureka, there is Consul, there is Apache Zookeeper. I'll explain you each of them so that you can answer you have to explain each of them. These are very popular choices available for service discovery and communication between the microservices. So Netflix Eureka is a service discovery tool which can be used to register, locate, manage microservices. Spring Cloud offers a set of annotations and auto configurations that are used to integrate Eureka into a Spring Boot application. So Spring Cloud offers a set of annotations as well as auto configurations so that you can easily integrate Eureka into a Spring Boot application. Second is Consul. Consul is a service mesh tool that offers service discovery, health checking, key value store features. Similarly, Spring Cloud also offers a Consul discovery client that can be used to integrate Consul into a Spring Boot application. Now comes the Apache Zookeeper. Apache Zookeeper is a distributed coordination service which is also used for service discovery and coordination in a microservice architecture. Spring Cloud offers a Zookeeper discovery client which can be used to integrate a Zookeeper, Apache Zookeeper, into a Spring Boot application. So once the service registry is in place, a client-side load balancer can be used to distribute the traffic across the available instances of a microservice. Spring Cloud offers a load balancer client and which is used to integrate client-side load balancing into a Spring Boot application. It plays a very crucial role here. It offers different services, set of annotations, beat set of annotations or APIs for integration and load balancing also. Okay, let's move on to our next question, which is what are the potential security vulnerabilities in a Spring Boot app and how they can be mitigated? There are multiple types of security vulnerabilities, and we'll be talking about each one of them and how to prevent them. So, first is SQL injection. Now, what happens in a SQL injection? An attacker sends malicious SQL commands to a database in order to retrieve sensitive data and manipulate data in a database. Here in SQL injection, a malicious query is being sent to the database to gather information, sensitive data, and to manipulate data. In a Spring Boot application, this can happen if a user input is not properly sanitized or validated before being used in a SQL query. So, if a user input is not validated or not sanitized in a Spring Boot application, then there could be a chance of SQL injection. And if some query is being given in without validation or sanitization. To prevent SQL injection, use parameterized queries or prepared statements instead of concatenating user input into SQL queries. By using parameterized queries, the query which is being triggered should only have the required parameters, hence it is more of a validated or sanitized form of that query, and instead of concatenating user input into the SQL query, this will help to prevent SQL injection. Also, validate and sanitize user input before using it in a database operation. This is the first type. The second is cross-site scripting, which is XSS. Here, an attacker injects malicious scripts into a web page, which can then execute in the context of the victim's browser. So here the attacker adds scripts into the web page, which can then be executed in the context of the victims, basically the user's browser. This can allow the attacker to steal sensitive data such as credentials from the user or session tokens. Now, once a session token can be acquired, the user can use that session to load it in some other browser or use it for illegal purposes. Now, to prevent these cross-site scripting attacks, ensure that all the user input is properly sanitized, which is very important, or validated before being displayed on the web page. Now, use a content security policy, which is the CSP, to restrict which resources can execute scripts on the web page. So there should be some policies which need to be defined by the Spring Boot application only, which will restrict which sources can execute scripts on the web pages. Also, use input validation and output encoding to prevent malicious input from being processed. So if you will use input validation, output encoding, this will prevent malicious input from being processed also. The third type is cross-site request forgery, which is very popular, and to prevent that, CSRF tokens are being used. So an attacker here can make a victim's browser perform actions without the victim's knowledge. So example, if you're using a web page, there could be some scripts running in the background that are performing some tasks without you getting them noticed. So this can allow the attacker to perform actions on behalf of the user or victim, such as changing their password or making unauthorized purchases. Now, to prevent CSRF attacks, use anti-CSRF tokens in your web forms and API request. So it is highly recommended that you should use CSRF tokens to avoid these cross-site request forgeries. This involves generating a unique token for each user session, including it any form or API request. When the server receives the request, it validates that token to ensure that the request is coming from a legitimate source. This is how you can prevent from being attacked and what are the types of attacks available. Moving on to our next question, which is define the ELK stack. Now, the ELK stack is made of three open source products. One is Elasticsearch, the other is Logstash, the third is Kibana. You need to explain these three first of all. So Elasticsearch is nothing but it is a NoSQL database which is based on open source search engine called Lucene. Second is Logstash. It is a data processing pipelining tool which accepts input from the sources, perform different kind of transformations and exports data to different targets. Kibana helps users to visualize data, just like there are other tools also, Tableau or Power BI. Kibana helps the user to visualize data with graphs, chart in Elasticsearch. The next question is, what is an IOC container? I have already mentioned about it previously. Now we'll be discussing about it. What is an IOC container? So IOC container, we talked about it during the dependency injection question. If you have skipped that, you can go back and check it out. So IOC container is a framework used for implementing automatic dependency injection. It manages object creation and its lifetime. It also injects dependencies into the classes. So it's nothing but a framework to facilitate dependency injection, and it manages object creation and its lifetime also. IOC container is used to create object of a specified class. It also injects all the dependency objects through a constructor, property or a method at runtime and disposes it at the appropriate time because it manages the life cycle of those objects. With this, one doesn't have to create and manage objects manually. This is the usage of IOC container. Now, you also need to explain to the interviewer all the containers provide easy support for the dependency injection lifecycle in different manner. So you need to explain the interviewer how these containers provide easy support for dependency injection lifecycle. So they provide that support for that lifecycle as below. First is register. The container should know which dependency to instantiate when it encounters a particular type, and this process is called registration. Second is resolve. So while using a IOC container, the objects needs to be created manually, and this is done by the container only, and this is called resolution. The container should include methods to resolve the specified type. It creates an object of the specified types, then injects the required dependencies and return the object. Then final is dispose. So the container should manage the lifetime of the dependent objects. The IOC container includes different lifetime managers to manage an object's life cycle and dispose it. So these containers, how the life cycle is being supported is by registration, resolution and disposition. So the next question is, what is Spring Boot dependency management? Now, when it comes to Spring Boot, it manages dependencies and configuration automatically. Now, you need to explain it to the interviewer how it does and what it is. So each release of Spring Boot provides a list of dependencies that it supports. The list of Spring Boot dependencies can be used in Maven. We need to specify the version of the dependencies or add the dependencies version in the config file in the configuration. Spring Boot automatically manages dependencies and it upgrades all the dependencies automatically, respectively or consistently at the time when we update the Spring Boot version. So you have to add those at the respective places and it automatically manages the upgrades of the dependencies automatically. Now let us also understand the advantage of dependency management in Spring Boot. So Spring Boot dependency management provides a centralized dependency information by adding and specifying the dependencies version in a required place. It also helps switch from one version to another with ease. This management helps avoid mismatch of different versions of the Spring Boot library. Here we simply have to write a library name specifying the version. So at a common place, you have all the dependencies added, and if you want to upgrade to a different version, you can directly specify that in that place, and you are good to go. So it provides a very easy way to upgrade to different versions, and yeah, you can switch from one version to another very easily. Moving to our next question, which is, what is the difference between request mapping and get mapping? So get mapping is a composed annotation, which is the short notation of request mapping. So if you know, a request method are of various types, which is get, post, put, patch, delete. So get mapping is a part of it. It's a short notation of request mapping where the method is get. These both methods support consumes. Consume options are text plain or application. The last and final question of the day is, what's your understanding of Spring Boot Actuator? Boot Actuator is a core feature of Spring Boot that enable developers to analyze Spring application metrics while the application is running, optimize, and wherever applicable. So during the runtime process, in order to analyze what is going on in the application, Actuator is a feature which is very helpful here. Aspects like currently running threads, CPU usage, beans is basically the objects, can be evaluated to optimize the application's performance. Through Spring actuators, developers can easily access REST points and gather information from multiple web sources. So it's more like at the runtime you can debug your application if something happens, or monitor for anything bad to happen, right? So this is where Spring Boot actuator can be very helpful. I hope you folks have understood the questions around Spring Boot. If you have any doubts, feel free to comment it down. We are very happy to help you. Thank you for all the support. The complete playlist is there for you. If you haven't explored the previous part of this particular full stack development series, you should go and learn them also. And this whole series will help you to get better or prepare well in interviews at big tech companies for full stack development role for senior level positions. Thanks for all your time. Make sure you like the video and subscribe to the channel for more such amazing content. Also leave a comment if you like the video, and if you have any questions also, the team will help you get through that. Thank you.